representing operations of sets on a Venn diagram. That's what we are going to do. So what do we do? I mean, when we have, this is a very important aspect of operation of a set, because when you are given a 3 sets or 2 set problem and you are able to represent it on a Venn diagram accurately, you have almost solved the question. Sometimes just by operating it or representing it on a Venn diagram, you can see the answers are very clear. So this is a very important aspect of operation on sets, representing it on a Venn diagram. From high school, junior high school, I've already considered Venn diagrams and 2 word problems. Alright, so we are going to go again and try to represent a set or sets on a Venn diagram. Alright, so when we have, so let's go straight to dealing with 3 sets of problems. Alright, looking at 3 sets, operating on 3 sets. So when we have A intersection B intersection C, right, how will we represent this? So let's say we have our set here. This is our A, this is our B, and this is our C, with this being our universal set. Then A intersection B intersection C is what can be found in A, can be found in B, and can also be found in C. And this is what can be found in all aspects, right? So when you are here, you're already in C. When you are here, you are also in B. When you are here, you're already in what? A. Alright? So when you have been given a question and give you a number of students or a number of people have all 3 sets or can be represented in all the 3 sets, and those people will be represented in this class, in this region. So let's say, they give you 3 students study all subjects. You know you have to write them here. Alright, now next one, let's go to say A union B. Okay, so within the same 3 problem, this time we are just looking at A union B. So A, B, C with this as the universal set. A union B is all that can be found in A and can also be found in B. We don't care about C at this case, at this point. So what am I shading? I'm just shading. Oh, okay, this is in A. Powerful. They are all in A. And this is also in B. So we are all. So when we talk about this region, it is just A union B. The same thing will be, a similar one will be seen for B union C. So then it will be just this side. And then when you talk about A union C, so it will just follow the same pattern. Alright. So we have our A, B, and C, right? So A, B, C. A, B, C. Alright. So if we have A, B, C, A intersection B union C. Now B union C is where? B union C is all of this part. Okay. So let's say let's use long diagonal lines to represent B union C. Okay, so when we are done with B union C, then we are looking at A intersection B union C. So what is found in B union C? So we do the bracket first, right? So B union C, we have it. Now what we can find in A and can also find it in what? B union C. What can we find in A and can also find in B union C? So if we want to shade A, okay, let's shade it at the other way, you know. Now if you look at this carefully, you realize that we have cross here in this section, and there's one pattern here, right? So where both patterns meet, just that will be the intersection. So we can just clean all this part off. So the one with just one pattern, we clean them off. Okay, if we redraw it, you realize that A union B. Sorry, if we redraw it, we realize that A intersection B bracket open union C will be just this place. Alright, because A will intersect with what? B union C at this point. No matter how complex the thing look, just apply the same fundamental knowledge and then you have it. Alright, so let's continue with examples that deals with complements. Let's say A union B or complement. Alright, so let's look at that. A union B or complement. So this is U, as usual, A, B, C. This is A union B or complement, though we don't really consider the C in this matter. A union B is where all that is in A and all that is in what? B, right? So when we want to talk about A union B, it's just this side. Complement means that all that cannot be found in A union B. So elements that can be found in A and can also be found in B are not part. We are dealing with all the elements that cannot be found in A or cannot be found in B. Where are those elements? They are outside A union B. Okay, so C is also part of outside A union B. C only. Outside A union B. Alright. So there you have it. I hope it's clear. It should be. Because if it was complement is just negative, right? The opposite side. So complement will say, oh, all that is here except for the set that is considered, right? So A union B will definitely be this. Complement means all that is outside A union B but can be found in the universal set. Alright. Now let's go on with, let's take another example. A intersection B intersection C complement, right? When we draw this, we are going to have A, B, C. So A intersection B, if we decide to go this way, A intersection B is what? Just this part, right? And then intersection C complement. So all that is not in C, all that is not in C, and can also be in, it will be in A and B too at the same time. It's just this portion. So this is where usually we will call A and B only. Alright, A and B only. So I hope you understand. C complement is all that is outside of C. Alright, C complement is all that is outside of C. A intersection B will be what is in A and also in B at the same time. This is also part of C complement. So this is where we have C complement, we have A, and we also have what? B. Any other place will not fulfill that. If you're outside here, you are just a C complement. If you're inside here, you are just in C complement and A. If you are inside here, you are just in C complement and B. But if you are inside here, you are in C complement, you are in A, and you're also in what? B. So A intersection B intersection C complement is this portion. Alright? The same thing. So if you look at A intersection B complement intersection C, that one too will be where? Will be here. A intersection A complement intersection B intersection C will also be where? Will be here. So it follows like that. Alright? Okay, so let's continue. Alright, let me do one more of these ones. So if we talk about A intersection B complement intersection C, what are we looking at? We are looking at the situation like this: A, B, C, A, B, and C, right? So A intersection C is here. B complement is all that is outside of B, right? So A intersection C would have been here, but then B is not part because we are in B complement, so we will come here. So A intersection B complement intersection C is sometimes what we will refer to as A and C only.